Hello everyone. Today we will start part 2 of chapter number 2 Polynomials, class 10th standard. So today our first topic is relationship between zeros and coefficient of a polynomial. So we know first we are discussing linear polynomial. Okay, linear polynomial we have discussed. Linear polynomials means the polynomials with degree 1. That means the variable will have power 1 only. And we know the general form of the linear polynomial is px is equals to ax plus b, and a cannot be equals to 0. Why a cannot be equals to 0? Because if we will put a equals to 0 in this polynomial, then the term with x variable will become 0, and then we will be left with only constant b. And if we will see only constant b, it is not a linear polynomial, because linear polynomial means there should be a term with variable and the power should be 1. So a cannot be equals to 0. So the general form of linear polynomial is px is equals to ax plus b. Now we have to find out the 0 of this polynomial. We are finding the relationship between zeros and the coefficient of a polynomial. So first we will find out the 0. Now we know 0 means the value of the variable which we will put in the polynomial, that polynomial should become 0. Or we can find out the 0 by just putting the value of the polynomial equals to 0. Now our polynomial is ax plus b. So if we want to find out the 0 of px, we will put ax plus b is equals to 0. And now if we will find out the value of x, x will be minus b upon a. We will transpose b to that side, it will become minus b upon a. Now if we will compare these terms, these b and a coefficient with the linear polynomial, so we can see that this b is the constant term of the linear polynomial, right? See, you can compare with the linear polynomial. B is the constant term. So here we have written constant term. And if you will see A is what? A is the coefficient of x. Okay, with variable x we have A. That means A is the coefficient of x. So in place of A we have written coefficient of x, and here it is minus sign, so minus sign. That means the 0 of the linear polynomial is minus b upon a. Okay, 0 of the linear polynomial is minus b upon a, where b is the constant term and a is the coefficient of x. This we have to remember. Okay, you learn this. Whenever we have to find out the 0 of a linear polynomial, it is always minus b upon a. And when we are saying minus b upon a, we have to take the general term as ax plus b only. Okay, and b is the constant term and a is the coefficient of x. So now what we will do, just take one example. I have a linear polynomial px is equals to 6x plus 7. Okay, we will find out the 0 of this polynomial, and then we will compare that 0 of the polynomial and the coefficient of a polynomial. We will do the comparison. So let's find out. Our linear polynomial is 6x plus 7, and then we have to find out the 0. We will equate it equals to 0. And when we will solve, we are getting x is equals to minus 7 upon 6. So this is the 0 of the polynomial. Now we will use this coefficient of the polynomials. So we know that the 0 of the polynomial we can find out with the coefficient of the polynomials also. We know x is equals to, or the 0 of the polynomial is equals to minus constant term divided by coefficient of x. Okay, the two ways we are finding the 0. First way, by equating the polynomial equals to 0, and after that we are getting 0 as minus 7 upon 6. Now we will find out the 0 of the linear polynomial with the coefficient of the polynomial, and then we will see whether both are same or not. Okay, now the 0 of the linear polynomial is equals to minus constant term divided by coefficient of x. Here we have written that. Okay, the same relationship we are using. Now constant term, if we will see this polynomial, the constant term is 7. So it will be minus 7. And in the denominator we have coefficient of x. So here what is the coefficient of x? 6. So it will be minus 7 upon 6. Now you can compare, this is also minus 7 upon 6 and this is also minus 7 upon 6. So there are two ways to find the 0 of the linear polynomial. Now we will take quadratic polynomial. See, we have already discussed that quadratic polynomials means polynomial with degree 2, and degree means the highest power of the variable. So suppose we have a quadratic polynomial. This is the general form of the quadratic polynomial. Px is equals to ax square plus bx plus c. This is the general form, and a should not be equals to 0. Right? If a is equals to 0, then the term with x square variable will become 0, and we will be left only with bx plus c. Now if we will see bx plus c, we can see the variable is x and the highest power of the variable is 1. So it will become a linear polynomial. So it will not be a quadratic polynomial if a is 0. So in case of quadratic polynomial, a is not equals to 0, and general form is ax square plus bx plus c. Now we know that a quadratic polynomial can have at most 2 zeros. Okay, the maximum number of zeros for a quadratic polynomial is 2. Now let's suppose alpha and beta are the 2 zeros of the quadratic polynomial. So first we will find out the relationship of sum of the zeros. The sum of the zeros is alpha plus beta, and the alpha plus beta is equals to minus coefficient of x divided by coefficient of x square. Okay, now if we will see the general term, what is the coefficient of x? Now see here, second term, with x we have constant b. That means coefficient of x is b. And what is the coefficient of x square? Now with x square we have coefficient a. So it is the coefficient of x square. So we have written that the sum of the zeros alpha plus beta is minus coefficient of x divided by coefficient of x square, and that is equals to minus b upon a. Now we will find out the product of the zeros. The product of the zeros are alpha into beta, and alpha into beta is equals to constant term divided by coefficient of x square. Now see, what is the constant term in the general form? If you will see the constant, now constant is here c, right? So we have written here c, and the coefficient of x square, if you will see, that is again a. So in the denominator we have written a. So we have find out the relationship between the zeros and the coefficient of the polynomial. First is sum of the zeros alpha plus beta is minus b upon a, and the product of the zeros alpha beta is equals to c upon a. Now let's take an example, and this is your NCERT example only. Question is, find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and the coefficient. Now see, this question is divided into two parts. In the first part we have to find the zeros of this given quadratic polynomial, right? And in the second part we have to verify the relationship between the zeros and the coefficient. Just now we discussed, okay, relationship between the zeros and coefficient of a quadratic polynomial. Just now we discussed that only we have to verify, but before that we have to find out the zeros of the quadratic polynomial. We know a quadratic polynomial will have at most 2 zeros, right? So here let the px is equals to x square plus 7x plus 10. This is our quadratic polynomial. Now we have to find out the zeros. Now what do you mean by the zeros? Zeros means the value of the variable. Now here variable is x. The value of the x, when we will put that value in the polynomial, the whole value of the polynomial should become 0. Or a second way, what we can do, whatever polynomial we have, we will put that polynomial equals to 0, and then we will find out the value of the x. So I am doing this method only. The polynomial is x square plus 7x plus 10. I am equating it with 0 to find the zeros. 0 means factors only. Okay. Now if you will observe this, this is our quadratic equation only. Okay, quadratic polynomial. And we know how to find out the factors of a quadratic equation. So what we will do, we will use the splitting of middle term method. This we have done in 8th standard also, we have done in 9th standard also. Okay. So we have written x square plus 5x plus 2x plus 10 is equals to 0. Why we have written 5x plus 2x? Because see here, this is 10. So 5 2s are 10. Okay, we have to choose any two numbers whose sum should be equals to this. whose product should be equals to this and whose sum should be equals to the middle term. Then 5 plus 2 is 7 and 5 2s are 10. So we have to find the two numbers. Now after this we will take these two together and these two together. So x is common. Then what is left? X plus 5, and here 2 is common. What is left? X plus 5. Now you know this method, and then we are getting x plus 5, x plus 2 is equals to 0. That means x plus 5 and x plus 2 are the factors of the given quadratic polynomial x square plus 7x plus 10. Okay, now we have to find out the zeros. Zeros means the value of the variable. So what we will do? First factor is x plus 5. So we will put x plus 5 is equals to 0. So we are getting x is equals to minus 5. Now second is x plus 2. We will put x plus 2 is equals to 0. We are getting x is equals to minus 2. That means x is equals to minus 5 and minus 2 are the zeros of the given polynomial. So first part we have done. We have find out the zeros of the quadratic polynomial. Now in the second part, now we have to verify the relationship between zeros and the coefficient. Now we will find out the relationship between the zeros and the coefficient of the polynomial. Now in the last slide we have find out the zeros of the polynomial, that is equals to minus 5 and minus 2. Okay, and we know that for a quadratic polynomial the zeros are alpha and beta. So we can denote it as alpha is equals to minus 5 and beta is equals to minus 2. Okay, these are the zeros of the polynomial x square plus 7x plus 10. Now we have to find out the relationship. We know the sum of the zeros. First we will find out with the value of the zero only. So sum of the zeros alpha plus beta. So we will put the value of alpha, that is minus 5 plus, and beta is minus 2. So it will be minus 5 minus 2 and that is equals to minus 7. That means sum of the zeros is minus 7. Now we will find out the product of the zeros. So product of the zeros is alpha into beta. Now we know alpha is minus 5 and beta is minus 2. We will multiply both and we are getting 10. So we have find out the values of sum of the zeros and product of the zeros by putting the value of alpha and beta. Now again we will find out the sum of the zeros and product of the zeros by using the relationship. And we have to verify whether both are same or not. Now if we will use the relationship, we have already discussed that the sum of the zeros alpha plus beta is minus coefficient of x divided by coefficient of x square, that is equals to minus b upon a. Right. Now if we will see here, this is our polynomial and we know the general term of the polynomial is ax square plus bx plus c. So if we will compare b is this bx. So value of b is minus 7. So I have written here, sorry, value of b is 7. So we have written here 7 and a is the this ax square. So here a is 1. So denominator is 1. So minus 7 upon 1, that is equals to minus 7. So sum of the zeros with the relationship is minus 7. Right? Now we will find out the product of the zeros. The product of the zeros are alpha into beta, that is constant term divided by coefficient of x square. Now again we will compare with the general term. Constant term is this ax square plus bx plus c. So c is 10. And coefficient of x square means here it is 1. So 10 upon 1 is equals to 10. Now we have to do the verification. Now see sum of the zeros here minus 7 and here also minus 7. Both are same. Product of the zeros 10 and here it is 10. That means both are same. So this we have verified the relationship between the zeros and the coefficient of the polynomial.